In this installment, we're going to look at the coefficient of sliding or dynamic friction. And the key word here is sliding. What happens when the block slides? Refreshing ourselves with our experiment, we had the stationary, which we've already dealt with, finding the coefficient of static friction. And now we're going to look at that case where it's traveling at constant velocity. What we found was the mean force applied, and therefore the mean force of friction was 5.773 Newton with a standard deviation of plus or minus 0.268. So we had 5.773 plus or minus 0.268 newtons. So the coefficient of sliding or dynamic friction, the mu d, would be the force of dynamic friction all over the force normal. Force of dynamic friction is 5.773, and the force normal we said was 10 newtons because it's equal and opposite to the weight. So that gives us a coefficient of friction of 0.5773 Newton. Not newtons, there's no newtons, the newtons cancel. 0.5773 newtons cancel. So that gives us our mean ratio. That is the coefficient of dynamic friction. If we were to calculate the upper limit, we would have mu dynamic, force of friction dynamic, divided by the force normal, and it would be 5.773 plus 0.268. All over 10 newtons. And the minimum ratio, the minimum coefficient of friction, be the force of friction dynamic over force of normal, would be 5.773 minus 0.268 all over 10. .773 So 0.6041 divided by 10, which we can do in our heads, 6.041, or we can just change that to 5.505. So we have 6.04 and 5.05. So for the upper limit, we end up with 0.604. We have two significant digits. We could report 0.60. And for the lower, we can report two significant digits. We get 0.505, which ends up being 0.51. So in the end, we can say that our coefficient of dynamic friction is 0.58 plus or minus 0. If we go to 5.8 up to 6.0, that's plus or minus 0.02. And if we go down to 0.51, I think I made a mistake. .505. That makes a big difference. And how I caught that was that I was looking for symmetry above and below, and I could see that it wasn't going to be symmetrical, so I knew something was awry. And so that's minus 3. So we'd say plus or minus 0.03. Which would give us an upper limit of 0.61 and a lower limit of 0.55. And notice we wanted to go with like 0.02 versus it was 2.60 was 0.02 above and 0.55 was 0.03 below. Again, we want to be conservative with our uncertainty, so we go with a larger number. So we have a coefficient of dynamic friction of 0.58 plus or minus 0.03. One last statement I would like to make about this is that there are several names depending on the different resources that you would use. There is sliding, which I really, really like as a term because it really depicts what's happening. The molecules are sliding past each other. Dynamic means there's some change going on. I like that as well. And the very common one that's used in New York State very often for physics is kinetic friction. The problem with kinetic is that it means moving, and it's confusing because what we already learned is for a car to move itself and propel itself, it's about static friction. It's actually that there's no motion at the location. So I find that using kinetic lends itself to a lot of confusion with students, so I don't use it. But if you see it, note that's what it means. Dynamic is nice because we have the D, and we can't use S for sliding because it's already taken by static. So mu S and mu D are what I will use, but dynamic means sliding friction.